Okay, limits of a function, part 3, the limit theorems. Okay, so there are several rules or theorems that guide us in our use of limits. They are intuitive, and for the functions that we will practice on for the next while, they seem kind of simplistic and even a little repetitive. Practice these, though, as they become necessary later on. Okay, so number 1, the limit of a constant, well, is simply the constant itself. Okay, so we kind of saw this in one of the earlier examples. Look, there's no x anywhere here. So as x approaches a, it really doesn't matter because there's no x at all. So for the little example here, the limit as x approaches 5 of 4 is just the constant itself. Okay, that seems pretty straightforward. Okay, number 2, the limit of a sum is the sum of the limits. So if I have a limit of two things that are added, well, really you can think of this as just the limit going to both pieces. So I just have the limit of the first function plus the limit of the second function. So this thing, the limit as x approaches 5 of those, is really the limit as x approaches 5 of x squared plus the limit as x approaches 5 of 2x. Well, remember, these are continuous functions, so 5 squared is 25 plus, well, 2 times 5 is 10, so the limit of this is just 35. Now, what's interesting right now is if I just put 5 into that function, so 5 squared plus 2 times 5 is 35, you can do it all in one step. That's what I was talking about up here. They're intuitive and they seem simplistic right now, because all the things I'm giving you are continuous. So if we just substitute in, we'll get it. But trust me, later on, this is going to be really helpful for you. Okay, so the difference of the limits of a difference is the difference of the limits. So again, if I have two functions that are subtracting, I just subtract the two limits. So this equals the limit as x approaches 5 of x squared minus the limit as x approaches 5 of 2x. Okay, so that is 25 minus 10, which is 15. Okay, the limit of a product of a constant and a function is the product of the constant and the limit of the function. So really what I do, if I have the limit as x approaches a of this, okay, I can just kick the constant right out. So the constant comes out in front times the limit of the function part. So how that works for this 5 just kicks out. So this is 5 times the limit as x approaches 5 of x squared. Okay, well, to figure out that limit, remember we just sub that in. So 5 squared is 25 times 5 is 125. Again, if we would have done that right at the beginning, just put 5 right in there. 5 squared is 25 times 5 is 125. So it works that way too. Okay, number 5. The limit of a product is the product of the limits. So if I take two functions and are timesing them together, well, all I got to do is find the individual limits and multiply those limits together. Okay, so this guy here, so this is going to be the limit as x approaches 5 of x squared times the limit as x approaches 5 of 2x. So this guy is 25. This guy, 2 times 5 is 10. So 25 times 10 is 250. Wow, that is a really messy 5. I'm sorry. I don't think that made it any better. Okay, anyways, here, let's fix. 200, there we go. That looks nicer. Okay, number 6. The limit of a quotient is the quotient of the limits. So again, if I have two things that are dividing, I just divide the two limits. Okay, so this guy here, so this one's going to be the limit as x approaches 5 of x squared divided by the limit as x approaches 5 of 3x. Okay, so that top part's going to be 25, right? Just put in the 5. Okay, and the bottom part's 3 times 5, so that's 15. Okay, well, 25 divided by 15 is a common factor of 5, so that is 5/3 is our limit. Okay, a couple more. The limit of a power is the power of a limit. Okay, so look, if I have some function, squared or cubed or whatever, so I just take the limit of the individual function and square it or cube it or whatever. Okay, so for instance, find the limit of x cubed. Okay, so really this is the limit as x approaches 5 of x all cubed. Well, the limit as x approaches 5 of x is just 5, so this is 5 cubed, which is 125. Okay, and last one, the limit of a power is the power of a limit. Okay, so this one I've put in a square root just for the fun of it. Okay, so really that limit sign can just kick underneath the root sign. Okay, and we can go from there. So for this guy, so this is the same as the square root of the limit as x approaches 5 of x to the 4th. Okay, so we've seen this already. So, all right, so the 5 goes in there. So the limit is just 5. So then 5 to the 4. Wow, that's big, 625, and then the square root of that, okay, is just 25. Okay, so, yeah. Okay, so anyways, those are the limit theorems, and again, we've picked examples that make them very apparent and very nice. Okay, let's try some more examples on the next page. Okay. Use the limit theorems to find this. So, oh look, this is a difference of limits. So this is simply the limit as x approaches 2 of 2x, okay, minus the limit as x approaches 2 of 3. Okay, well this limit is just 4. This limit, remember there's no x in the 3, so that's just 3, so equals 1. Remember, guys, these are continuous functions, so if we just put the 2 in there, 2 times 2 is 4, minus 3 is 1. So we don't need the limit theorems, okay, just for these simple ones, but we're going somewhere with this. Okay, so number 2, as x approaches 5, well, okay, so this is the limit as x approaches 5 of x squared plus the limit as x approaches 5 of 2x plus the limit as x approaches 5 of, oops, that's a minus 3, so it's a subtraction. We're subtracting the limit, okay, of 3. Okay, so this guy here is 25 plus, that one's 10, and then the limit of 3, or limit as x approaches 5 of 3 is just 3. So minus 3. So that's 35 minus 3. So that equals 32. Now, until these get harder, guys, really what I want you to do is just substitute straight in. It will become apparent when you need to break these up like these. So, and that's not right now. Okay. So looking at this, find the limit using the properties of limits. So we have a quotient, we have, okay, all we have to really decide is that, okay, remember x can't be negative 2 here, or else it opens up a whole other can of worms. But look, x is approaching 1. So we're not discontinuous there. We don't have an asymptote. We don't have a hole. So we could just substitute that in. Okay, so 1 to the 4th, okay, is just 1 minus 5 times 1 to the 5th is just 5. Okay, and then plus 1 over 1 plus 2 is 3. Okay, so 1 minus 5 is negative 4, plus 1 is negative 3 over 3, which is negative 1. Okay, and then the last guy, so x is 3, so 3 squared is 9, plus another 3 is 12, so this is root 12. Okay, well, that's all swell, but remember guys, you're in Math 31, so I do expect you to reduce root 12. Root 12 is 4 times 3, so that kicks out the 2, so this would be 2 root 3. Okay, that's it for this one. Go ahead and give the formative assessment a try. Thanks, guys.